Hi, and another really neat little problem here that will highlight just how powerful the bar model way of visualizing a maths problem is. Okay, so let's have a look at this. Amy has 2 bottles of juice. She drinks 1/3 of the juice from the first bottle, and she drinks 1/4 of the juice from the second bottle. There is now the same amount of juice in each bottle. At the start, there was 60 ml more juice in the first bottle than the second bottle. And the question we are asked is how much juice was in the first bottle at the start? Okay, so we know that she drinks 1/3 of the juice from the first bottle, and that tells us that she has 2/3 of the first bottle juice left, and she drinks 1/4 of the juice from the second bottle, which tells us that 3/4 of that juice is left. Okay, so what we're going to do is we're going to draw 2 bars. That's for bottle number 1. This is for bottle number 2. Okay, so what we want to do is we want to draw something. We're going to draw 2 blocks because we want to represent. I'm now going to represent what's left. Okay, so I'm going to represent 2 equal size blocks. That represents what's left. That's the 2/3 that's left. Okay. Okay. Actually, I don't know why I did that, but anyway. So that's the 2/3 of the first bottle, and she drinks 1/4 of the juice from the second bottle. And then this is a really important bit of information. There is now the same amount of juice in each bottle. So whatever I draw is going to start here and it's going to end here, isn't it? Okay, but I need to have 3/4. All right, so there's going to be 3 here. So I need to think about how I can represent 3. And here we go. We're going to have 1, we're going to have 1, 2, and 3. Okay, so there we have 3/4 being the same size as the 2/3 up there. See, even people with terrible handwriting can do bar modeling. Right, so that's the 3/4. Now, what I'm going to do is I'm actually going to, because what I've done here is I've sort of divided things up. It's always nice to have everything having the same size parts, the same units involved. Okay, so that's how my model looks now. And what are we told? Well, we know this is what was left. We can now draw in what there was in the first place. So what I'm going to do is draw in another third. So here we go. This is what there was in the first place. And I'm going to draw in another 1/4. Okay, there we go. There's another 1/4. I'm going to mark them in the same way. Okay, so I've got that's been taken care of, that's taken care of, that's taken care of. Now, at the start, there was 60 milliliters more juice in the first bottle than the second bottle. So that's the difference here. That's the difference between the first and the second bottle. And we're told that that is 60. And of course, you can see how that is equivalent to one of these units. Okay, so all of these units, I can go and label them all if I wanted to. I don't need to. They all have a value of 60. And that means I can work out whatever I want now. So how much juice was in the first bottle at the start? Well, this is what I should have done. So this is my question mark. That's my question, isn't it? So, and how do I work that out? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need 9 times 60, which gives us, so 10 times 60 is obviously 600, so 9 times 60 is going to be 540 millilitres. And that's our answer, 540 millilitres. Right, a nice simple bar model there. I hope that helped.